Welcome, everyone, to Mark Voids a Warranty. I decided to start a minute early because last time I had some connection issues and I just wanted to give myself a little bit of a buffer in case that happened. So while we're waiting for noon to roll around and the party to really start, I wanted to share a quick story with you. Last week, or it was probably started about 3 weeks ago, I saw this particular lens, and you can barely see it here on screen. Sorry about that. This is kind of a temporary mount just while I learn how it works. But essentially, it's got an infinite focus. What's the best way to do that? There we go. It's got an infinite focus so that you can... whoop. No, that one's out of focus. An infinite focus so that you can zoom in on stuff without having to refocus, which is really cool when you're doing a live stream. People don't want to wait while you do that. See, like now, who wants to deal with that? I know I don't. But it's got this other cool feature, which is down at the bottom. It's got a mirror that can shine things at oblique angles. So let's see if we can't take a quick look at it, shall we? It is on input 1. I know, exciting, right? So the first thing... more light, maybe? Uh-oh. I've angered it. Let's unpower and power back on. This might be a very short demonstration. Yeah, it's the trouble with live stuff. It never works right when you want it to. Okay, well, I'm going to have to work on that and see what's going wrong on that input. That's unfortunate. I was going to demonstrate it to you today. It's probably what I get for unplugging it. Oh well, what are you going to do? Anyways. All right, that should be it. That should be about time. So welcome everyone to Mark Voids a Warranty. Thank you, those of you who joined me today. My name is Mark, and I like, we'll call it fixing things. I like fixing things with hammers. And last week, my options included this sledge and this brass hammer. But the universe has provided a little 3-pound drilling hammer, little machinist hammer. Isn't that purty? We're going to see if we can't find a use to use this today where a better tool would probably be useful. Yeah, what are you going to do? As we go through, if you do have any questions, please ask them in the comment box below. I'm not really watching Discord. It's hard to keep track of everything. So just do it in the YouTube if you don't mind. And I will welcome all of my Teach Me PCB members out there. Teach Me PCB is a course that just started. If you hurry, you can still sign up at teachmepcb.com, where we're teaching introductory printed circuit board design. And this year's project, a macro keypad. So we're going to teach you how to reprogram the Raspberry Pi Pico into a user interface. This is a brain in the shape of the Teach Me PCB brain. So if you're at all interested, you want to know more, or maybe learn a new EDA that you can use at home, like KiCad or Eagle, join us over there. We've also got a Discord community as of Monday with 100 members already. It's pretty crazy. So if you're interested, join us there soon. All right. Today, we're taking apart a microwave. A lot of you have been asking for this one out there. What's in a microwave? How does a microwave work? And it actually starts with the platter. That gives you, I don't want to say it gives you a hint, but you might have wondered why this is in your microwave. Well, you see, microwave generates a frequency of about 2.4 gigahertz, and that wavelength is such that you can get hot spots and cold spots, spots where the energy is concentrated as it bounces back and forth inside your microwave. So the purpose of this is that wave is going to have it's going to generate hot spots in the same spot each time. So you spin the food around so that the food enters that hotspot region, right? I don't know if that kind of makes sense. But if it doesn't, next time you go get yourself a big old Symphony or Hershey bar, take the tray out, just put it there, put the microwave on for 30 seconds, and you'll see that the chocolate only melts in certain locations and not in others, which is pretty interesting. So the platter spins around to help prevent that. So let's get that out of the way and see what we're getting ourselves into. That's going to make noise the whole time. Yarr. All right. Here's what we've got. Panasonic microwave. Yeah. Now, Panasonic did not want me in this microwave. Because on the back side, let's see if we can get an overhead view for you. They put security screws everywhere. Now, I couldn't find the right bit. That happens sometimes. So all I did, let's see if we can show you these security bits here. It might be way too close. So all I did was, where is it? Yep, way out of focus. Sorry about that. I went ahead and took them out just with a pair of pliers. And that should let us get this back open. I promise I haven't done anything more than that. So we're hitting the first obstacle. Oh, this is going to make such a mess. I hope I moved the sodas out of the way. Let's do that before it becomes a problem. So the first problem is that the case doesn't want to fully open. And I don't know yet why, but we're going to find out. It could slide, it could pry. Oh, it just slides. Darn it, that was almost a hammer time obstacle. Okay, we are having fun. So what we've got is a cavity that houses the large part of the machine. And over here, let's see if I can move my cameras. Let's get a single source split view going. So over here, we've got the first board, which has a couple of relays and the power connection. So we're going to disconnect that and make sure this puppy is de-energized. What do I have for that? I know it's unplugged, but I'm going to get a pair of insulated wires anyway. Trouble with these quick connects is they tend to not want to come out. Sometimes. I might have broken that. That happens a lot in Mark Voids of Warranty. We're fast and loose with the rules here. Okay. Oh, another one. There we go. And ground. All right, so there is what's left of our first board. Sorry, board. It happens. So it looks like you've got, well, you had a, current coming into a pretty simple board overall. We've got some solder, what appear to be solder thieving pads right here. So when this thing goes through wave reflow, those things will suck up a little extra and prevent solder bridges from forming, but I don't really understand the pattern they used there. There's an isolation transformer, so this thing passes high current through one side, it gets turned into a magnetic field that then goes to the other side, and that other side is what you've got. So if anything short circuits inside the machine, right, there's ever a really big mechanical failure, what happens is that side of the transformer just simply stops working. So you can't have a high current short in a microwave. That's the reason that they do this. You've also got a fuse, so in case anything, too high a current goes through, it goes. And possibly a fusible link right there. I'm not really sure what that is. And then two relays, or no, these are two capacitors, I'm sorry. So just two big capacitors. So this is just a board for a high current machine. You'll notice that there's a lot of separation between all of the connectors. That's for creepage and clearance standards, since this is a high voltage, high current device. And overall, I mean, that's our first board. And its whole job, take energy, line power in, convert it into a magnetic field, that then this wire converts back into an electrical current. It's just a short circuit mechanism inside the machine, in case some crazy guy comes at it, you know, with a hammer. You never know. You never know who's going to open these things. All right. There's quite a bit of electronics in here that I need to figure out how to take apart while you are here with me. Also, as I go through, if you do have any questions, please don't hesitate to ask. I see a few of people are joining us today, hopefully from Teach Me PCB. If so, say hey. No, you can't say hey. I've got the only microphone. I tricked you. All right. This is just a support strut. That has to go. I can't even see what I'm doing. I really can. I'm doing this by feel. Just because of the way the cameras are positioned. So hopefully this is the screw that comes out next. I don't know. If it's not, you'll have to tell me. Okay. Feels like there might be, that's not loose yet, so there might be another strut, or it might be time to pull out the band hammer here. We're just going to leave that folded over for now. I wonder if I can get you a better view here. Oh, this has to move. There we go. So I'm just fighting with this little strap right now. See? It wanted to fall off. So we've got quite a bit of circuitry going on in here. Sensors, control, keypads, all sorts of stuff. The Magnetron. So the Magnetron is a device that when you put high voltages into it, it creates a radiating electromagnetic field. This is generally what engineers try not to do with their circuits. So that is a little piece of, it feels like Teflon around this connector. So I'm guessing this is just a high temperature shield of some sort around that wire. So that Magnetron must get hot. Going to get rid of some of these. We don't need them anymore. Interesting, though, that they would have this connected in such a way, though. I don't really know what that's about yet. Maybe we'll find out. All the wires are color-coded. That makes assembly and repair easy on whoever has to do that. Another one of these things. So here's our microwave lamp. And a lamp base, it seems to be seized. So I guess that's just a single replaceable part. Well, that can go in the trash. Not going to need that anymore. You'll see holes throughout here. Whoops. Get that turned off there. You'll see holes throughout here. As long as the holes are smaller than the wavelength of the electromagnetic wave, it can't escape. And these holes are going to end up being several times smaller, usually. So light and other things can get in because they've got a much shorter wavelength. But the big stuff, the high energy stuff that would fry your Wi-Fi, it can't. If you ever want to ruin somebody's day, take a microwave apart and point it at their house. They will have no Wi-Fi. You'll probably also be committing a felony, but you know, hey, you do you. I'm not telling you how to live your life. All right. Right now, I am just trying to work my way through this cable harness, and I use that term loosely, to see what all I can get loose. I think we're going to be better off, rather than trying to pull all these connectors, these quick connects, to just cut them. You need a sharp probe to get it. Oh, of course, that one comes off. That's the way it works. Oh, well. Once again, if you have any questions as I go through this, do ask. I don't mind at all. They are a little delayed on my end. They take a few seconds to come through. So if you have the question before you have it, that would help. Okay. I'm making some progress in here. Could make more if I had a good view of what I was doing. Getting some of these things off and down. Who knew destroying a microwave could be so much fun? Did you? I didn't. What is holding that safety interlock in place? Maybe the door? Yep, the door. All right. So here's the first bit of engineering interesting stuff. They have these snap action limit switches. And there's two. Or are there three? It looks like there's three. My goodness. They are not fooling around. There are three switches whose job it is to know that that door is closed. Now, since I took this apart in pretty rapid fashion, I don't know how they had those wired. It could be that you need all three switches to show closed before it allows you to turn the microwave on. It could be that one's there for redundancy. So as long as you have two working, it works. I don't know. I kind of went through things too fast. But that lets you know they're serious about having that door closed when that microwave's on. They do not want that thing open. You don't usually see that level of safeguard in consumer electronic devices. A lot of devices will have a single safety interlock, and if that fails, the device does not turn on, and that's it. You're done. Get this one out with a screw. See, we have some new people joining us based on stream stats. Feel free to ask questions. Make this an interactive experience rather than a VCR one. Okay. We are progressing. I am continuing to take things apart that might get me closer to my goal. You know something? I wonder if I can give you guys a little more light. We need to change this to not be flashing. There we go. And turn that down a little so it doesn't overpower the things. Let's see how that works. Marginal improvement. But at least you can see what I'm taking apart a little more. We're trying to get to the high voltage supplies here. Get that Magnetron out. And then maybe we'll take a look at the control panel. Be honest with you, I didn't actually anticipate this much going on. I'm moderately impressed. But only moderately so. Should have taken this whole thing out to a bandsaw and taken off this whole half of the machine before I even started. And we haven't gotten to use the big hammer yet. That's always exciting. All right. How do we do it next? Oh, there's screws. One of my, while we're doing this, I would like to say one of my colleagues had his car stolen today. If you are a car thief, you should stop that. It's not nice. If you know any car thieves, you should tell them to stop being bad people. I once had my car stolen. I was 18, I want to say. I might have been 19. I don't really remember. It was 30 years ago. Well, not that old. 25 years ago. I had my car stolen. And like 8 days before that, I was diagnosed with cancer. I'm like, seriously? Life does that sometimes. Okay, looks like we've got access to the Magnetron. Wahaha. Come on. There we go. There is Mr. Magic Magnetron. Isn't that cool? So we've got, presumably, what are the heat fins for heat dissipation. That is a fancy arrangement, though. You never see that. And QR code object tracking. So if any of you out there want to learn more about this and share it with the group, that would be cool, because this was not meant to be opened. I can, but if time permitting, we'll open this and we'll go through the physics of it. But I'm going to set that off to the side for now, because this is already taking a little longer than I anticipated. Ow. There we go. All right. How do we get this bad boy out? Come on. I want you out of there. Get rid of that. I see a screw. Sometimes if you don't know how to take things apart, just start taking apart the obvious things and see what happens. Wonder if I get a better view of overhead. I do not. There has to be another screw in there. I've got to move above this thing. Yep, there's one way over in that corner. How do you get to that? You know, I'm beginning to think they didn't want me to get into this. Those rapscallions. So there's a screw way back in that corner. That I need gone. Let's see what I have in the old toolbox here that might be able to handle that. While I'm looking, I would love to know what brings you guys by today. What marketing tool we used that allowed you to find us. We've been advertising on Discord, on LinkedIn, on all sorts of other things. Okay, this is going to be painful, but this will work. So what I'm looking at, and I don't know if you guys can see, there's a screw way back in that corner there. And I imagine it's accessible through this hole if you have a really long screwdriver. I don't have one that's that long. I don't even have one in the garage that's that long. But you know what we could do, since we're not trying to repair this. Okay, that didn't work. What else can we do here? Can we get access to the plastic? Let's see what we can do. Let's see if we can get rid of this motor. Uh-oh, I lost my screwdriver bit there. Whoops. I guess I'm the reason I can't have nice things. So I'm going to see if I can't take out this fan blower and see if that doesn't increase my accessibility to this project. By the way, please feel free to like and subscribe. Once we get this channel to 500 subscribers, I'm going to take apart that giant lens that's sitting directly behind me that says Canon on it. It is a production TV lens used in some Hollywood TV show. I don't know. I picked it up at a scrapyard. Okay, this is getting ridiculous. Okay. All right. This is your notification to turn off your headphones for a minute. Hey, look. That came right out. You can turn them back on now. Yeah. Bye, motor. Bye. All right, so the motors are cool. Up until the fact that I just beat it with a stick. These types of motors are simplicity themselves. So you've got an iron core right here, and then a coil of wire that goes around it. And this is an electromagnet that sends pulses. And as it pulses, that changes the magnetic field inside this core of wire, which then causes the permanent motor, or I'm sorry, the permanent magnet to rotate. So it's just kind of a push, 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 push type situation. Kind of cool, I think. Okay. Don't worry. We can fix that. Oh, hey! Would you look at that? Popped right out. All right. Get rid of that. So the plastic is there to prevent arcing and also to prevent technicians from electrocuting themselves. Let's get rid of that. Goes to some safety interlock somewhere. Or some sensor, I don't know. All right, so we've got... Tell you what, let me get this out of the way. Give me a sec here. Breaking a sweat on this one, huh? All right, so we've got the power board. And this guy has a couple things on it that I can point out to you. I wonder if I can get you a close-up look. Wrong button. Give me a second here. I'll get it figured out. Let's try that. Okay. So we're zoomed in here. We've got a 4-pole device. Usually whenever you have a 4-pole anything near AC, it's a rectifier. So it takes AC and it converts it into DC. And then over here too, we've got what looks to be a 3-pole. So this is some sort of transistor, most likely a FET, depending on the currents involved. It might be an IGBT. I don't really know without scoping up part numbers. A couple of what look to be capacitors, a toroid, Really an unusual one, too. A transformer with multiple winds, and it looks like maybe high current. Are they doing Linz there? I don't know. Then over on this side of the transformer, we've got a part baked right into it. I don't recognize that. If any of you out there in TV land do, please let me know. It's possible it's a diode. It's possible this is part of the safety mechanism, you know, some sort of a fuse. That F would make sense for fuse, but I don't really know. Couple caps, and then was that a resistor? I don't know what that is. That almost looks like a wire round resistor in a package. I don't know. I don't deal with high voltage enough to say with certainty. But what this thing will do is take the power from that other board, the first one that I pulled out, that guy, right? After it goes through the isolation transformer, it'll come into here. Now here, they're converting from a lot of winds into a few winds. And whenever you do that, you're changing the voltage and the current simultaneously, right? So you get, on one side of the transformer, high voltage, low current. On the other side of the transformer, low voltage, high current. And depending on which way you go, you know, that'll affect what happens in your device. All right. So on the back side here, you can see some PCB features that you may recognize, and I see some that I don't. One, I see slots in here, right? They route slots when you're worried about creepage. Anytime that you have any two conductors on your PCB, any two of these, you know, these copper bits that are at a different voltage, as time goes on, it'll start finding a way. It'll start carbonizing the dielectric material, and it'll create a short circuit condition. Well, you can't do that if there's no path. So if the electric field gradient is high enough between one area and another, right, danger high voltage area, this part here, and over here, you can prevent that creepage from occurring with slots like this. And there are guidelines. I want to say IPC 2122 covers it, but I sometimes get those numbers wrong. So don't take my word as gospel on that if you figure out it's something else. But that's for high voltage designers. They have to worry about creepage and clearance. Creepage you can deal with, right, by potting or cutting slots in your board. Clearance, you just have to actually have physical clearance. You can put an insulative material in between them to increase the clearance level. But engineers tend not to do that. They just move it across. And then down here, amazingly enough, in this power control board, we do have a little baby IC. This is not at all the cleanest board I've ever seen. I mean, there's a lot of schmutz. I don't know if that's oil from cooking or if that's some sort of conformal coating they put on, but it just looks yucky to me. It doesn't look like a good conformal coat. Anyhow, so this is going to be monitoring and controlling the switching that happens. And basically the way that it occurs, you'll take something like this and you'll dump energy into these wires. Those wires, as the charges accelerate, dump energy into a magnetic field that you can then go and extract. And you can use this to change either voltage or current as you go through. So anyways, high voltage boards, man. Fascinating stuff. I don't know how we're doing on time, but if we do have some time, I might do a little disassembly on that transformer. Let's get that microwave back and keep going, huh? Which scene do I need? This one. Okay. So now I am trying to get to the control screen, and for that it seems like I need to go through the bottom, get this stuff apart. Welcome, by the way, Andrew. I did see your post. Thank you for letting us know. Anybody else out there that's watching, let me know how you found me. Always interesting. Also, like and subscribe. Tell your friends. Once we get to 500, I take apart that lens right there. I've been waiting for it for far too long. I'm getting itchy. Yeah. Okay. Down underneath here, I've now freed up the motor. This is that nice turntable motor that spins everything around. Looks like it runs off 120 volts, 6 revs per minute. Might come in handy for a project, I don't know. But that's not what I want. I want this. I want the control panel. Some interesting things on this control panel. Mostly the cheapness with which they produced it. Get out there. Oh, one more. I know I'm blocking your view. It's just for a minute longer. Also, feel free to ask questions. That's why I'm doing it live and it's not a recording. Also, I don't currently have time to edit my videos. Okay, so here we go. There we go. So a couple interesting things on this board. I mean, obviously I angrily destroyed some things. But you'll notice there's only copper on one side. That is an extreme cost-saving measure, right? They are doing everything they can to save money. It also might be, if there are some high voltages coming into this board, maybe they were worried about their dielectric breaking down in plane. I don't really know. But they got their traces run all on one side. With the exception of spots where they couldn't do it, they used these little jumper wires. Right? Somebody has to sit there and do that, but it's something that can be done. This is a little Piezo Buzzer, right? That's what those things look like. Couple diodes. This is an off-board connection for the control panel, which is still in the board. This is just the board behind the control panel. Relay? What is this? This looked like the power coming in. I don't know. Maybe it's a relay. And we've still got that same schmutzy coating that just has the hallmarks of, you know, brushed on flux. Looks icky. But you can see that they are still paying attention to creepage and clearance with a lot of these. They didn't use extensive copper pores to provide proper separation. And they're fencing out the high voltage area just to let the technicians know, you know, don't poke there, danger. Not only will it kill you, it'll hurt the whole time you're dying. Yeah, this must be some brushed on conformal coating. I can see brush marks. Anyhow, you've got your IC that's running the LED control panel, and it's the brains of the unit. And then that is the display. So the way these things work is pretty interesting. So the first thing, the light that comes through the back, it's all provided by those 3 little LEDs. And it enters in here and it gets spread out. Right? Nothing fancy. No Fresnel lens or anything. You've just got a white case and then a white diffuser. Simplest thing in the world. Now inside here, you've got polarizing film and this stuff called liquid crystal. Let's see if I have do I have a light handy? I guess this one. So if you look, you can kind of see through and you can see different colors. So what you're doing with an LCD is you're putting voltage through and you're causing these little, I don't know if it's really a polymer, but you're causing these crystals to rotate and realign themselves. And that affects how light travels through the LCD. I don't know how they glue these together, but I know this is going to break. I'm okay with that. Just need to make sure I clean it up. Here, let's do it this way. See if you can see the colors as it's stressed. A little. So here I'm stressing those crystals mechanically, right? Usually we stress them with electricity, and you can get them to change color and rearrange their patterns, and then you can start seeing things through them. It's all terrifically fascinating. So if you ever, wear gloves, but if you ever get to take one of those things apart, you're going to see a polarizing lens inside. You won't be able to do anything with the liquid crystal, unfortunately, but you will get this little polarizing lens inside, and sometimes you can do some neat stuff with that, with physics. Okay, all sorts of fun to be had. Back to the Magnetron, baby. Woo! Mark made a mess. That's another TV program we're starting. By the way, if you have any suggestions for how to make this more entertaining or more interesting or more educational or more anything, let us know, man. We are just trying to provide, or at least I am trying to provide value, and my company's supporting me in doing that. And if that means I'm taking stuff apart, I'm taking stuff apart. If it means I'm doing something else, then I'm doing something else. You just have to let me know. Be vocal. So the backside of the Magnetron is crimped shut. Don't want this falling off. Don't want people really playing with it, because the energies are potentially hazardous to humans. Check that out. Let's get you on Zoom. Whoop, there we go. So here we've got our connections. You've got what appear to be copper running around. I don't know if that's ferrite, if that's graphite, but it's kind of got that dark gray look to it. And that kind of looks welded. I mean, that doesn't even look soldered. I don't know how they put that together. 4 rivets on the back. And then that connects to our Magnetron gun. Now, how we get into that, I don't know just yet. I'm sure they don't want us in there. That looks like it twists. That looks like it's no, those are loose. Ha ha ha. Big, what appear to be ferrite cores. Let's see what happens. I don't know if you can hear in the back, but my... Uh-oh, it's punching through my... Whoops. All right. Plan B. We need protective material. Come here, Chester. Okay. We just need something cheap we can put down to protect the work surface. There we go. I just dropped some hundies. That should do it. Okay, here we go. Let's try that again. Nothing yet. You know, I'm beginning to think they don't want me to take this apart. I'd do a Dremel, but it's far too slow. Okay. Break free, little one. Break free. There we go. All right, so for those of you playing along at home, we've got this little ring that acts like a gasket, and it just seems to be woven in compressed copper or brass wire. Now the next part might be a little harder because it is indeed riveted in. They don't seem to want me to get back there. But they haven't made a mark-proof thing yet. Okay. So again, this is the exit hole. That's the part that points at your microwave. It's where the radio energy is released. My screwdriver, my pliers, are sticking to this. It is the Magnetron after all. Come on. There we go. So, a magnet. On the back side, we've got another magnet. Okay, I need to show you this. This is interesting. It's floating. So in the Magnetron, the parts that you've seen so far, right, other than that little metal shield I just destroyed, that's doing a little bit of flux movement, you've got these two giant cylindrical axial magnets, and that core that goes into the other thing goes into there. All right. Let's get this work surface out of the way there. Before you think I'm completely nuts, I was using this as a prop in another video. Right, it's just paper. I made a video ad earlier where I answered that as if it was a phone. Okay, now, man, we're having trouble and I've only got 12 minutes left. I've got to get this off the ceramic part below. There we go. Okay, so this is the protective can emitter that goes into your microwave, and behind that you have what looks to be, and we really should put this on a higher magnification, a very sharp point. Can I get that in? Which camera needs to focus? There we go. So this is, I doubt it's copper, but it kind of looks coppery. And it's duck-billed in the front where they've crimped it to a very, very, very sharp edge. And surrounding that, with a very low clearance, was this little triangular aperture. So they're doing something here to create the escaping magnetic field, the escaping electromagnetic field, right? Those things are designed to interact with each other in a really bad way. Well, I mean, it was intentional in this case, but that sharp edge, they're doing something with. Now that part should probably be welded below. I don't know if I can get that out. No, I think the rest of it's going to need a Dremel. Okay, I'm going to lose vacuum here. If I didn't already. I think I did. Okay. So underneath, and I really should have gotten something here for us so we could get a better look, but underneath you've got a axial rod that's connected way back here to the back side of this. You know what I need? And if anybody wants to Patreon this to me, just give me a water jet. We can just slice this right down the middle. Okay, that's welded. Can't do anything about there. This is welded or press fit. I think we are done with the Magnetron. Okay. Well, I was hoping to get a little deeper inside and we could talk about the physics of it. Because there is some neat physics in there, but right now it's just me talking, and you might as well go to Wikipedia for that. But anyhow, that was a thing. All right, I've got a couple minutes left for Q&A. If anybody out there in TV land has questions that they'd like answered, I'd be happy to entertain them. So let me give you guys a minute for that. While we're doing that, remember, we've got... oh no, where's my demo board? Almost got lost in the shuffle. While we're doing that, we've got Teach Me PCB. We're going to learn how to make your first board. That should be exciting. I'm excited for you. It'll be a fun experience. We've got the Discord server. And as always, we've got AAPCB, Advanced Assembly, and Royal Circuit Solutions as your favored printed circuit board manufacturer and assembler and sponsors of this video. So I'd like to thank them very much. If there aren't any other questions out there in TV land, I'm going to go nurse my wounds. Yeah, that's when I slipped and it hit the case there, and go from there. So the question is, how did I cut my finger? It actually happened during the video. I don't know, about 10 or 15 minutes in. I hit it against the case of the metal frame of the microwave. So it's probably going to get infected, get gangrene, fall off. You know, it happens. Now, when you're taking things apart like this and you're not taking your time, per se, or doing it the right way, you know, and I'm going to use air quotes because I don't do things the right way. I do it the hard way. Sometimes injuries happen. I'll go wash it out. It'll be fine. All right. With that, I hope to see y'all over at Teach Me PCB. Next week, I'm going to do a rundown on soldering irons. A lot of people are wondering what kind of soldering iron they should have in their home shop. So I've got a few of those on order from Amazon. We're going to go over them and look at them together. I'll pull out a thermal camera. We'll see if their thermometers are right or not, and we'll go from there. Other than that, it has been a pleasure to have you all join me today on Mark Voids a Warranty. I'm here most every Friday. I don't know if I'll always be, but for now I'm here every Friday tearing stuff up and using hammers. By the way, I like this one. This is Max Forged Hammer. It smashes stuff good. So, all right, everybody. I really appreciate your time today, and thank you. And please like and subscribe, and you'll get notified the next time I do a live stream, and you'll be around next week when I do the soldering iron run.